And welcome to the Daily Space Weather Show. We'll be showing you the freshest imagery of the closest star, as you may have come to expect from the channel. So thanks for tuning into the Smash News Network, least busted name in news. These are 24-hour videos from SDO. And here's a little closer look at the northern polar region. We've had a dip in sunspots since yesterday. The X-ray flux has also dipped, and the most likely place to see a large solar flare is becoming sunspot 3559, which is up in the northwestern limb. It's looking like the most magnetically complex sunspot at the moment. The new active regions over on your screen left, the eastern limb, are looking pretty magnetically simple. Here's a southern polar view, and we'll come back to the AIA instrument here momentarily. Before we do that, we'll take a brief look at the Solar Dynamics Observatory's HMI instrument. So sunspot number continuing to dip here as several sets of sunspots set in the western limb. The rising sunspots have not been able to replace them, so we'll see a continued dip in sunspot number unless something drastically changes in the next 24 hours. There's a colorized magnetogram. Let's take a brief look at volcanoes. These are what is currently going on as far as volcanism goes. We've got Ibu, Semeru, Popocatépetl now back to exploding, producing a flight level 200 over central Mexico. Also got Santiaguido, Fuego, Sangay, and Brevenador. Don't forget Sabancaya. And let's move on to earthquakes. So first, the 90-day bar graph. There you go. There are the past 90 days. Largest quake of the past 24 hours was a 6.1 in near a fairly populated region there in Guatemala. Kind of off toward the hills was the epicenter, but there are quite a lot of signs of civilization nearby. So lots of people likely to have felt that one, and it likely did some damage there. There's a location of that 6.1 magnitude quake. It was from early this morning on January 27th, 2024. We'll get to it. The quakes of a 5 and greater magnitude included a 5.1 at Micronesia. Papua New Guinea had a 5.5 at great depth, over 200 kilometers estimated depth. Turkey had a 5.1. And then less than an hour later, a 6.1 strikes Guatemala at 5:52. That was also at depth over 100 kilometers. Estimated depth for the Guatemalan quake. Kyrgyzstan had a 5.0 at 9:03 this morning. And then 30 minutes later, Indonesia had a 5.4. Then a lull in 5 and greater magnitude quakes until a 5.4 strikes Tonga. That was at 16:13, and then less than an hour later, a 5.1 strikes Papua New Guinea, and then Philippines had a 5.0. That was also at depth, over 150 kilometers estimated depth. So quite a few deep quakes and quite a few quakes of a 5 and greater magnitude. Let's get back to space. Here comes some more SDO images for you. There is 335 angstroms. And here we've added 304 angstroms. So that's a composite 335 plus 304. Ionized iron and helium together. And let's talk about some space weather stats next. The 10.7 centimeter radial flux now down to 146 solar flux units. There is the 1-year graph to contextualize that. Radial flux is the black line. Sunspot number is the red line. Okay? Space Weather Enthusiast dashboard showing a decrease in likelihood of geomagnetic storms. Yeah, there were no strikes. I mean, we expected like 4 CME impacts in the past few days. We had nothing noteworthy. So By the way, pardon my magic shirt. I didn't cast a spell on it. It's just a magic shirt. I don't know what to tell you. Anyway, no likely space weather on the way. Next, our Earth's magnetic moment from space, our geospace magnetosphere movie. And again, things are geomagnetically calm, so not a lot to show there. This depicts magnetohydrodynamic pressure. The model is the space weather modeling framework, and the units are nanopascal. Since it refreshed, I'm going to let it play through. And FYI, these videos are not edited. So we basically treat these like a live stream. That way they get onto your screen as quickly as possible. After all, it is quite time-sensitive data. Past 4 hours of Earth's magnetic moment from space. Past 4 hours of Earth's magnetic moment from the ground. If you want to read about the space weather modeling framework, head to the Geospace Magnetosphere Movies page, click on Details. You'll find a link to the space weather modeling framework. It'll show you all the data that's used. You can even download it yourself if you want to make your own model. That's the past 4 hours of Earth's magnetic moment from ground level, nanotesla. Changes to Earth's B field. Here's our planetary K-index at 1, KP1. Again, geomagnetically calm conditions. Next, some solar wind data. And the ACE has been offline here for a while. Let's go to the Discover. Current conditions there. About 8 protons per cubic centimeter for the density. Solar wind velocity here, only 362 kilometers per second. It's quite slow, with a nominal solar wind density. GOES magnetometers remain smooth. And let's move on to our top view ecliptic plane field plot. So here we go. Earth is on its way to a North Pole magnetic sector. I would expect by tomorrow's video that Earth will be in that North Pole sector. I don't see anything to stop it at the moment. So likely sector boundary crossing in the next 24 hours or less. Here's our line of sight field plot depicting the solar B field in blue, photosphere magnetism in grayscale, and the polar fields in green and red for north and south respectively. That is the past 4 days, which brings us to coronal holes. That's the line of sight coronal hole plot, and you can see some North Pole oriented coronal holes rotating in here. A completely expected uptick in coronal hole activity. So it's been forecasted on the channel for a long time. And now the shortage is ending. Let's get the coronal holes from SDO's perspective. And we're not expecting any major solar wind from either of those coronal holes. They are both of South Pole magnetism. Next, it's time for sunspots. Sunspot number continued to dip here, now approaching 60. Yeah, it's only about 65 sunspots here at the moment. Again, expecting that number to dip tomorrow. And check it out. Most likely place for a large solar flare is sunspot 3559. So I've now moved on to 3559 as my favorite sunspot for a large flare, although it's not really that likely there either. Here's our flare probability monitor and scoreboard. And let's take a look at sunspots a little bit closer up from the SDO. So here we've put together 131 angstrom 60-minute running difference along with the SDO continuum. And there is that one new sunspot right down here. It did get a name. It's looking pretty weak. Let's subtract the 131 angstroms to make that a little bit more easy to see. So, okay, this group here rapidly formed. And now it's been stable. Actually, it looks like it's degrading once again. So, looks like possibly a very short-lived sunspot there right in the Earth-facing zone. It does have some chance of producing solar flares. Although not particularly exciting, I must say. Continuing on, let's move to energetic particles and solar flares. No spikes in the proton flux, no relativistic particles. Background X-ray flux is still in a C level, about a C1. We had a recent little uptick here, but barely anything. And some CMEs happening as we make the video. We'll get to it. First, let's take a look at 94 angstroms from SDO. So there still is a possibility of large solar flares in that southwestern limb as well. So mainly the northwestern limb for the next couple of days here. But for the next about 36 hours, the southwestern limb also has some possibility of producing some large flares. And next is our star chart. So that's what's going on overhead Lehigh Valley, PA. And if you're new to the channel, let us know where you're located. By the way, thanks to our new YouTube subscribers. Congratulations on finding the channel. And if you're out looking at the sky over Lehigh Valley right now, you might see the Constellation Signis. My personal favorite. It's an exciting part of the galaxy. Not only is the strongest radio source besides the sun located in the Constellation Signis, also the only known cosmic ray point source and the brightest intrinsic object visible, at least in the X-ray spectrum, also in that constellation. Cygnus. It's pretty cool. Next, we'll show a solar system forecast. So that's where things are today. That's where heavenly bodies will be on the 3rd of February, in 1 week, as Earth moves through this lonely side of the solar system devoid of gas giants. Next, our astronomy photo of the day. It's from Chile, the Atacama Desert. That image taken from 9 miles away from that observatory. And, of course, the full January moon there, rising over that double Magellan telescope. Those are two 6.5 meter diameter telescopes at the Las Campanas Observatory in Chile. Next, coronal mass ejections. I like coronal mass ejections. What about you? Let us know in the comments. Here are our CMEs from today. And we had some events that look like they might be earthly directed. Sadly, they're not. So these are all non-Earth directed events in my opinion. And if I show you something that proves me wrong, make sure you let us know in the comments. If you're mad about space weather or a lack thereof, definitely let us know in the comments. We encourage all rage comments, and we do read all comments, even if we are unable to respond to them all. So there's a C3 and C2. And you may see some events there that look a bit halo-like. They're not earthly directed. So here is the composite imagery, and this will sort of solidify things for you. We do have a comet there showing up, coming out of your lower left screen there, the southeast as it is. And that comet looking like it did not make it into the C2. So that comet looking like it's disintegrated, being vaporized by the solar wind, or perhaps by radiation, or a combination of the two. But anyway, there you go. So, yeah, we don't see any major filamentary motions happening associated with these CMEs, the ones that have halos. They look like they're on the far side of the solar disk. Not too surprising, as there are a lot of sunspots roiling over there. So here's another view. We've dropped the C3 here and added the 193 angstrom 60-minute running difference. And yeah, you're not going to see any major plasma motions on this side of the solar disk associated with any of those halo-like coronal mass ejections. So those are not earthly directed. And here we'll zoom in even closer before we get to solar filaments, as those wavelengths are fantastic at showing filaments. 304 plus 193 angstroms running difference. Quite good at showing great depth. Great depth, and you can see those dark absorption features there. Named after two of our viewers, by the way. So there you go, more fantastic 24-hour imagery. And it's always a delight to bring it to people just like you. Anyway, now getting on to filaments. Filaments, filaments, wherefore art thou filaments? Because of magnetic fields suspending you and allowing you to defy gravity. Some prominences remain in that southeastern portion of the solar disk. Here's the colored imagery, which shows a little bit greater detail in the solar disk itself. So still some significant filaments there, which could turn into major CMEs, coronal mass ejections. Although they could also collapse, they could reorient themselves. And before we get to bonus features, let's show you the current CMEs that are occurring as we make the video. So three different events really there happening all at the same time. Looks like at least 2 prominences, but it's likely to be 3 additional coronal mass ejections, and those are not likely to have any Earth-directed components either. That's the GOES 16 SUVI for the past about 2.5 hours. And let's move to bonus features. First, satellite charging hazards. We don't have them. It's smooth out there for satellites. No surface charging hazards where low-energy electrons build up on spacecraft, and no internal charging hazards where high-energy electrons build up in spacecraft. GOES electron flux remains very low, and it's an ongoing shortage. There you go. There's the past year. And it's the biggest electron shortage of the entire year so far. So there it is. Here's the forecast model, NOAA expecting nearly flat levels. And I tend to agree, because we need some space weather to cause a shakeup in the electron flux. Next, we'll show the layer where it's measured. The F layer. Don't be effed. Know what's going on with the effing F layer. So here it is. It's located at about 300 kilometers of altitude. And there is its vibrational signature, the ionosonde, as it is. I like to call it the ionogram. And things are very calm, as there have been no geomagnetic storms for an extended period of time. And if that's Greek to you, don't worry. We'll also show the anomalygram, which depicts anomaly in megahertz from the 30-day median. So yeah, not so exciting. Space weather has been quite calm. Next, the whole atmosphere model, showing the total electron content on the left and the maximum usable frequency on the right for high-frequency radio use. It's the second last segment in the daily space weather content. We'll close out with the latest imagery. There you go, high-res imagery from SDO. And again, this new sunspot down here is looking pretty weak. It's barely existent. There is one that rose here right near the equator. It's alpha class at the moment, only one polarity umbra there, only one umbra period. And then this one here is looking pretty weak as well. It's weak. That is weak sauce. And let's get to weather. So meteorology's next. Now that we've done the space weather, let's bring the weather home. Anybody want to guess where the coldest place in the world is? There's the coldest place in the world, and it's a cold day in hell when you're able to sneak up on a dragon in his own lair, so don't try that. That would be a huge mistake. Dragons, not surprisable in their own lair. They have a 0% chance of being surprised in their lair. Now, would you like to guess where the coldest place in the world is? 60 degrees below 0 Fahrenheit, folks. Where is it? Where do you think it is? Come on, let us know, and let us know in the comments. Leave a comment. I know typing is a real pain. Try using voice to text. That's fun. Anyway, the coldest place in the world is in Siberia. So there it is. That's colder than Antarctica. That's colder than Greenland. That is colder than your ex's junk. Next, wind patterns for the whole planet. Ta-da! There you go. Wind patterns. How you like them apples? Surface winds of the east. Jet streams of the east. Strong jet stream in the West Pacific. Jet streams of the central world. Cold air being blown deep into Africa. Surface winds of the central world. That's Europe, Africa, and the Middle East. Surface winds of the west, aka the Americas, and the jet streams of this side of the planet. Another cold pocket here making its way down with Canadian air into the central plains. Next, clouds and fog. And we have a low making its way from Missouri, into Kentucky and things. We'll get to it. It's visible right there. And how about a little closer view of that, as it is in charge of the weather from the Mississippi Valley to points east. There you can see that low pressure there, just making its way through the New Madrid fault zone, folks. And ahead of that, a little bit of thunderstorm activity. So we're going to show some forecasts here briefly. That's rain accumulation for the next 3 days. We'll show the Euro model. So there's the Euro model for rain accumulation. And look at Washington. Washington is going to get plastered with rain. This area here, expecting over 5 inches. So that's rain accumulation for 3 days on the Euro model. Here's snow accumulation for the next 3 days on the Euro model. And we'll also have the GFS models here in a moment. First, the weather.gov map, and lots of flooding on the map there, quite a bit of storm activity there, lots of counties lit, lots of waterways lit. If your location is lit, click your location at weather.gov. Those are too many counties to cover. Here comes some forecasts, starting with the GFS 72-hour pressure and precipitation. Next, rain accumulation in inches for the same period, the GFS 72-hour model. Next, snow accumulation in inches, GFS 72-hour model. Last but not least, temperature anomaly forecast in degrees Celsius for the GFS 72-hour model. We show 3-day forecasts because they're accurate. They might not look spooky on the thumbnail, but they tend to be accurate. Once you get to a 4-day forecast, the inaccuracy is higher than the accuracy. In other words, the accuracy drops below, I'll say, 42% at about 4 days. That's my story, and I'm sticking to it because facts, they're very controversial. So pardon all the controversy and all the facts. So there's that thunderstorm we showed yesterday. It's finally now moving its way to the east, about to crash into Florida, making its way across the Gulf. So there you go. There's the current situation. That's lightningmaps.org's real-time lightning map. Next time you hear thunder, check it out. Perhaps you can convince the natives that you are Zeus. Only 71 strikes per minute on a global scale there. Not very much lightning. Some weird lightning there up in northern Norway. Check it out. That's pretty weird. Some lightning way up there near Arctic Norway and Sweden. That's odd. Anyway. Moving right along, here is our Doppler radar map, and that's that low we were telling you about, bringing lots of precip to the Mississippi Valley and points east. Tallahassee, the worst of it's behind you. It'll clear up in the next couple of hours. Here's a full 50-state view briefly. Doppler radar depicts vertical motion in the air column. We'll focus on the lower 48 view for the remainder of this video. So there is precipitation. There are clouds and fog. And there is water vapor. A great view of that low pressure there as it's making its way to the northeast. Here's your recap. Ground-based Doppler radar systems. They'll show you precipitation if they're calibrated correctly. They'll definitely show you vertical motion of water droplets and ice crystals. Shortwave radiation shows you radiation emitted by the water of clouds and fog. 3.9 micrometers is the wavelength. And 6.61 micrometers is the wavelength of water vapor in general. It'll show you the dry air, the moist air, and the in-between air. So there you go. When your Doppler is unclear, break out the water vapor map. And we hope we were clear with all of those facts. Anyway, may that solar wind be at your back. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And I'm headed back to the bunker. Bunker time, because I'm spooked of space. Oh, watch out, folks. There are galaxies and all kinds of spooky things out there. Remember, because when a thing is big, it's very scary. Be spooked of all big things, folks.